My name is Matt Bernhardt. I am the Global Solutions Architect for the Cyber Resilience Vault. Wanted to do a couple things with the Vault, as Chris was mentioning. I want to take you through a deeper technical dive. Want to help you all understand why it is we can look at bringing folks, or having, I should say, folks ready to begin doing workload recovery much quicker than what I would call the standard backup-based vault solution. So we'll dive into that, dive into a bit to the architecture, why it is we use the hardware that we do as part of this solution. And then as I go through it, obviously any questions along the way would be great. It's most effective, especially on this architecture build out slide, to just have communication. Just to lay the groundwork quickly here, again, when we talk about the cyber resilience vault solution, this is what we're talking about. We're talking about hardware, software, in what we call the landing zone. It'll be more clear here in the build out. We have the vault zone that has hardware. You'll notice in there we include a layer of switching because that vault zone is entirely isolated in air gap. I'll also let you know that as part of this all-encompassing solution, it comes with either 3-year or 5-year maintenance, as well as a full implementation and documentation and runbooks customized to the environment that get left behind. So as we get started here, some of this should look familiar from what Chris has already covered. There is on the left in that green box essentially a very basic VMware environment. We have ESX host, we have some storage underneath, we have vCenter to manage it all. We have Zerto layered on top. You see the red box there, the ZVM, the Zerto Virtual Manager. Think of that again as the manager of the overall Zerto environment. Its job includes a number of key functions, including talking to vCenter to understand the kind of layout of the ESX environment, know where those VMs are that you've asked us to protect, know where those storage is that's connected to them. It also provides a web GUI for those that prefer that, as well as hosting a full set of APIs, which we see a lot of our extremely large customers like to use in order to automate activities. The last thing it's responsible for is those VRAs, virtual replication appliances. The VRAs are the data movers in our environment. So their job is to watch for new and unique data to be created on the VMs you've asked us to protect. When we see a new block, we'll make a copy of it. We'll stick it in our VRAs in memory temporarily. We'll also do that inline detection that Chris was talking about earlier, looking for anomalies, looking for encryption that wasn't there before. If we see something, we will say something, but we'll report on it, as we mentioned. Not only we're going to let you know that we see something and we're going to give you kind of a criticality rating, but we're also going to tell you which which VMware clients were impacted, as well as the disk that we saw that on. And this can be really helpful to a security team that got that alert that they need to potentially have an issue that needs to be researched. We're kind of sort of narrowing down and making smaller that haystack that they have to go find the needle in by giving them a good starting point because of what it is that we saw going on there. The other thing we're going to do, and you saw that earlier in the recovery points, the checkpoints that Chris mentioned, there are typically every 5 to 10 seconds is what you'll find in terms of your recovery points. And what Chris was showing you there is additionally, when we see something, when we see what we think may be a ransomware or an encryption event going on, we're going to let you know which checkpoints are clean and which ones may have that infected payload. So we're giving you quite a bit of information out of the gate, not only letting you know near real time, right? That block, that new data gets created, we immediately see it, make the copy, and we immediately scan it and take a look at it. So it's a very timely detection process of the data. You'll notice also kind of tucked there in the corner that says physical server in the green box. I think as we're all kind of well aware here, there's always seems to be a few of those left in the production environment. Often they're very critical to the business. So, while Zerto is the traditional product, if you will, is focused on virtual workloads and protecting them and being able to replicate them, the cyber resilience vault has the ability to work with physical machines, whether we work with, the RMAN tool to protect the Oracle database, or maybe we're working with a backup tool, a backup product to protect those physical workloads. But just know that we have that physical protection capability there. In this landing zone, and if you think back to what Chris went through in detail, think of it as like the DR or the target site. We're going to have the Zerto environment again sitting on top of the VMware environment built out. We've got a couple of ESXi hosts. We have a vCenter, and then you see again the ZVM and VRAs. The purpose of this environment in terms of protection is that the blocks that are new that get replicated, they get replicated into the ZVM VRA environment in the landing zone. That's where the journal sits. That's where the capabilities of recovery initially, those first availabilities come from. And in fact, when Chris took you through what the recovery process looks like, same idea here, right? If you're fortunate enough, and I use air quotes, I'm fortunate, I guess, but if you're attacked or your organization gets hit with a ransomware event, and it's fortunate in that it's minimal, not effective, maybe it impacts a VM or a subset of data, files and folders, or maybe an application, you can immediately go to this landing zone, use that recovery flow that Chris was showing, and see within those checkpoints which ones are clean and which ones aren't. And your potential impact from that ransomware event could be minimal. It could be a matter of minutes in terms of getting that application back. However, that's not always going to be the case. Obviously, if you think of the stories we see in the news, the casinos in Las Vegas, some of the hospitals have been hit, the government, there are a lot of far more sophisticated attacks going on out there that are far more reaching in their kind of blast radius, if you will, and quite a bit more damaging to the environment. And that's really where something like this vault solution comes in place. So we look again, we see the Zerto replication represented by that purple dash line going from production to the landing zone.
So Matt, sorry to interrupt you. This is Mac Norcillar again. I do have a question before we go into the architecture of the vault itself. So looking at the production side, you do have inline detection capabilities when you're protecting VMs through the ZVM. However, when it comes to physical servers, I guess that this flow doesn't go through Zerto, right? Or are you does it go through Zerto as well?
No, that's a great point. So that data movement is managed by the backup or the tool that they're using. Like I said earlier, the RMAN, or I'll mention Commvault. It's just one of many, backup vendors. Okay. And in that case, we are going to be relying on the solution that they have, right? There are things out there that like Predator and CyberSense and some of the others that work specifically for physical workloads. Okay. And so those will play a part.
So when it comes to the way your customers are going to consume the cyber resilience vault, are they going to get all of that as a service? That means as a consumer, do I need to care about which third-party tool you're going to be using, to protect the physical servers, or do I get that out of the box from you?
So,
and if I can continue just to develop the argument, yes, especially from a detection perspective.
Yeah, if I understood you correctly, the solution right now, we are getting a lot of requests, a lot of interest in as a service type of models. And we've certainly modeled that, and that's been part of an offering from within our HPE teams. We've had partners that have stepped up to want to do as a service. Right now, today, the majority of folks have elected to manage this themselves. They're using they generally have their data protection team, so they know that backup solution for the architecture. And then for the physical workloads and how that plays out and works. And then we also have the ability to provide at the end of a run book. So it's a relatively simple set of steps to get that recovery back. And I'll actually take us through that here in a couple of slides. Was I in the area of what you were asking? I wasn't.
Absolutely. Thank you very much.
Okay. Thank you. So looking back here again to the architecture. So we've got that landing zone, as you can see. It's got some storage in there. It's got the servers. We put a jump box in as this kind of the central point of management. And then all that data gets put in either from the physical servers using their data protection tools, or for the virtual workloads using Zerto CDP model. When that CDP model moves data into the landing zone, as Chris mentioned earlier, it goes into that journal. And that journal is what gives us, literally oftentimes thousands of recovery points in a day to choose from. So now, how do we get that data into the vault zone? So on a periodic basis, what I often see with our customers is in a 4 to 6 hour range typically, but it can be shorter, it can be longer. We are going to enable the connection between the storage device in the landing zone and its partner in the vault zone. So we'll enable that connection. We will then replicate across any data that's collected there since the last replication job. And then once it gets in there, we'll go ahead and create an immutable copy. So the underlying storage is Electra MP. And one of the features in the MP that we're taking advantage of is something called virtual lock. And virtual lock is, by my definition, is basically just hardened immutability, meaning once you set a deletion date, there's no getting rid of that data. You can't come in and make the data short, make the deletion date earlier, go check a box and delete it. Not even, for that matter, somebody from HPE, including development or support. Once it's locked in with a date, it's locked in there. So it gives you that hardened immutability. In the vault zone where that data is sitting, I mentioned the storage. There's also a layer of switching. This vault zone is, again, completely isolated. There is no outside connectivity. In fact, it is so isolated to make your initial connection, to have your initial interaction with the vault, you actually have to physically go to the rack that is housing this equipment, go to the jump box we list here, log onto that, and then from there, there's a management network inside of the vault that will allow you then to interact with the different hardware pieces, as well as do recoveries and testing. We've got, again, the servers. We make sure the servers, so as we talked about that solution and we mentioned the ProLiant server, we're very specific in what that hardware is going to look like, meaning that, for instance here, the servers in the landing zone are identical in build and specification and SKUs and everything to the servers in the vault. And it's very important to our recovery flow and our recovery sort of flexibility or capabilities, and I'll explain that in a couple of minutes. You'll notice below those two ProLiant servers is a third one. We put that in there to be available. It's a standalone ESX host for it to run services that may be required in the vault. So it may be that it is running scanning services for the physical workloads. If the customer wants to scan their physical workloads once they get in the vault, it could very well be running an NTP server since we're isolated and not knocking out. That's important. It's just there to provide resources, again, for additional workloads and additional capabilities and functionality. So in terms of moving that data into the vault, that's the flow. That's what it looks like. Once we make that immutable copy, we are now ready to begin working with the data. And when I say working with the data, at this point, we can stand up the environment in this vault zone. Again, being that it is so isolated, it's a great testing area. You can do tests anytime you want. It gives you a chance to validate your documentation, ongoing training for your staff. Again, security team can go in and use it. Think of it again as a clean room, production gear, as Chris mentioned earlier. So the SecOps team can go on and potentially do some analysis and remediation or some testing as well. It's fully intended to be able to run your environment, your protected workloads in a completely isolated environment. In terms of what else can we do, at this point, we have this copy. We are ready, if it need be, to do a recovery because of a ransomware attack. So one of the critical things to understand that is really unique to us versus those backup-based vaults is at no time when I talk to this flow did I mention the need to do any type of backup of the data. And because we're not backing up the data in terms of the virtual workloads, we're not having to recover it. So what we've seen, we do obviously with the physical servers can get some backup data in there, tends to be a very small percentage. So that certainly plays a part, but getting back the virtual workloads, we don't have to do any type of data recovery from backup. While our competitors are spending time recovering from a backup environment, a backup, device, if you will, all we have to do is go in and pick one of our immutable copies, clone it, make it read write, and now we're ready to go. So what takes us a matter of minutes is going to take a lot of these other vendors, days and potentially weeks.
So
I'm going to stop there for a second and see if there's any questions on.
Yeah. So it's me again, Max Mortillaro. So the isolated, the test and recovery environment sits in the landing zone or in the vault zone?
So for isolated testing and recovery, it's going to be in the vault zone.
Okay.
In the landing zone, you can do limited testing. Like, for example, Chris was showing you earlier in his kind of walkthrough screens what it's like to recover a VPG or a VM. And it's, pick that VPG, pick that application, pick the recovery point and go. You can absolutely do that anytime in the landing zone. What you do is you recover it to what's called the test network. But that does not give you the full, I have to rebuild my environment. My environment's been taken down and I need to go through a full, cyber recovery. For that type of testing, that takes place in the vault itself, the vault zone, I should say. Okay. That makes sense?
Yep, thank you.
Cool. As Chris was also mentioning earlier, we do have the ability to vault and protect public cloud workloads. Some specific examples would be, native Azure, native AWS, or any number of VMware as a service up in the public cloud. When we talk to customers about this, we always want to make sure they understand the potential for egress charges when replicating out, the potential additional time when it comes to recovering, because there is always going to be, not always, there's typically going to be an impact of that connection from on-prem back to the cloud that can impact, moving large amounts of data. So we're always clear with the customers, but we want to know that want them to know it's there. You can check that box. The other thing we're kind of demonstrating here in this lower left with that DR box is with Zerto, there's a capability to do something called one-to-many. One-to-many means I can protect a VM to up to 3 locations at the same time. In this particular design that I'm showing you right now, and this is just one of many options, I have put the Cyber Resilience Vault, the red box, in the same data center with production that I am providing cyber recovery for. And I'm doing that largely based on recommendations that you can read out there, but the primary reason is speed of recovery. In a large-scale ransomware cyber event, the amount of data that is likely going to need to be recovered could very well be significant, and we need to prepare for that. And so one of the recommendations is put the vault, any vault, put it in with the workload that you are protecting, that you want to recover back to. And that way you can take advantage of in-data center network speeds rather than being potentially penalized or slowed by WAN connection speeds between 2 data centers. Obviously, this architecture doesn't do well, or isn't going to cover your more traditional DR event, right? There is a geographical event like an earthquake, fire, maybe workers cut cables. That's not good. The vault is not there to protect against a traditional DR event. In that case, you would use Zerto's one-to-many to replicate that second copy to the geographically separated DR site. We certainly have architectural capabilities with this ability to put the cyber vault at a DR data center. We just want to make sure we understand the customer's network speeds and potential impact to the recovery time. Excuse me. All right, let me move on. I want to show you what the recovery flow looks like, kind of give you an idea of kind of hopefully bring everything together, why we've architected it this way, why we're using the hardware that we're specifically using, and where we have some distinct advantages. So what I'm showing here on this screen is just another representation of the Zerto Cyber Resilience Vault being connected to a production environment. In this case, as you can see by the labels, production is outside the red box. It's one of the boxes. Landing zone is a box. Vault zone is a box. The yellow dashed lines between production and landing zone represent the continuous data replication that Zerto does. And then the black dashed lines in the lower middle between landing zone and vault represent the storage replication that we periodically do. So this is just what Zerto, or sorry, the Cyber Resilience Vault looks like in what I'll call normal operations, day to day. Nothing is going on causing any issues. If I take you through a scenario of recovery, and I'm going to use what I call the worst case scenario, the good case of ransomware, but the worst case scenario where the customer, the organization has been impacted by a more sophisticated attacker, patient, right? They got the payload in there into the production environment. They've gone ahead and sat quiet for, let's just say, a month. And in the meantime, that payload, while dormant, has managed to copy itself into the landing zone. It's very likely in the vault zone, probably in all the backups, the tape copies, the cloud copies. How are we going to deal with that? So while we have a team that is rebuilding essentially the production environment, the landing zone environment, we're going to go into the vault zone and begin preparing the data for recovery. So think of this as like a two-step process. Number one, prepare the data for recovery. Number two, the recovery itself. So to prepare for recovery, the first thing we're going to do is we're going to select a snapshot. As I mentioned earlier, we're pretty sure at this point that the payload has gotten into all of the snapshots, or at least the last 30 days worth. Organizations really don't want to go back that far, prior to the introduction of the payload. So let's go ahead and take the most recent snapshot where the payload is dormant. So we're going to go ahead and select that. We are going to clone. We're going to make a read-write copy of that point in time snapshot. We are going to mount it to what I call the scanning VM. So this, again, most often when we talk to organizations, they have the scanning tools they want to use that they've had faith in, they're trained up on, they've invested in. The core thing here is that tool needs to be able to scan Linux-based file systems. Because what we're doing when we move that data, or when we storage replicate that data from the landing zone to the vault zone, is we're simply taking the the VMware environment, the ESX file system, VMware file system, and that is what we replicate into the vault, and we keep it in that format, so that once it's in the vault and it's in that immutable format and it's the VMFS file system, that all we have to do is clone it. We've still got it in VMFS file system, Linux file system at the very core. So we're able to scan it with the tools and go through and do the remediation and the cleaning that needs to be done. Once that completes, we're ready to start performing the recoveries. At this point, I have a couple of options. I can recover from the vault zone back to production. I can replicate those clean volumes to landing zone and then recover from the landing zone back to production. But because the way I built the solution, or we built the solution, we have the exact same compute and the exact same storage in the landing zone that is in the vault zone. So through a simple ESX configuration backup and recovery that we do every day through automation, we can flip those vault zone clients and turn them into the landing zone clients. What do I mean by that? The compute host in the vault zone with a single recovery command take on the host name, the IP address, and the UUID of the landing zone. And by doing that now, I can go ahead and bring those clean volumes mount directly in the vault and be ready to either start recovery directly from there, or perhaps SecOps, like I said earlier, wants to do some testing. The other thing that backing up the CSX configuration does for us is, in the event that the attack is or includes encryption or destruction of the ESX config, the ESX environment itself, so attacking at the ESXi level. Now we have a backup of the host configs in the landing zone. So as part of the recovery process, we just lay those back down once we've reinstalled ESX, and we're right back and ready to recover. So let me just kind of take you through this recovery process. So at this point, there's been a team that has reinstalled ESX and cleaned up production, cleaned up the landing zone. As you can see, all they've installed in production at this point is this Zerto Virtual Manager, virtual replication appliances, and a vCenter. So first thing we're going to do is we're going to establish that connection between the storage, and we're going to replicate the volumes back over to the landing zone. We're going to then assign the volumes to the landing zone hosts. Remember, this data came from those hosts. We've already applied the config that matches the time of this snapshot. So simply now just go and power on the vCenter, the ZVM, and the VRAs. Takes about a half hour, 40 minutes for them to come up and kind of shake off the cobwebs. At which point, we start using that Zerto recovery flow and workflow that Chris talked about earlier, right? Pick the application, pick the VPG, pick the VM, recover it into that landing zone. Now have the application team or the recovery team go ahead and make sure that the application is running correctly. And once they bless that, you'll use Zerto to do a Zerto migration back to production. At this point, we have the first set of applications back in production, and we can go ahead and do the next set. So think of the landing zone as really a staging area. When we design and architect the vault, we don't build it out, purposely don't build it out to have all the compute that matches production to be able to run all the VMs at once. That's just very cost prohibitive. What we will do, and some customers want to do this, then we will size the landing zone, the vault hardware, to be able to run a subset of applications that the organization has identified as the minimal applications they need running in order to take care of their customers, in order to run their business. So we have a lot of flexibility in terms of sizing, right? If we want to go ahead and increase the host CPU and memory because we're going to bring in more VMs potentially at one time, increase the storage. It's all very granular. It's all very modular. I'm going to stop there and take a breath. I see the clock just under 5 minutes. See if there are any questions at this point before we kind of wrap it up.
So Matt, Sky Fugate here with NetSmart. I just had a quick question. So what do you typically see customers doing from a scaling perspective for your landing zone and for your vault? Are you seeing kind of what they need from well, we want to be able to recover X amount of VMs at a time, or what do you see in that regard?
Yeah, so we have a modeling tool, a sizing tool that we use. The first couple of questions are, how many, and I'm going to switch to kind of give you an idea here. How many virtual machines do you want to vault, and what is their storage capacity? That's kind of our starting point. And based on those numbers, you can see we have 4 sort of entry points into the vault world. And then the next few questions that we're going to have as we narrow things down is, what kind of physical workloads might you want to have? To your point, how many have you identified a set of applications that are minimally needed to run the business, and would you like to size for that? We also talked about obviously the physical workload capacity and growth. So through this modeling tool, we find again these sort of entry points, and then we build up from there. A lot of times what we find is very few people fit this exact model. Very few people are 300 VMs and 300 terabytes of space needed. It's usually I have 400 VMs and 200 terabytes or what have you. And so we can increase the license count and then decrease the storage. So significant flexibility in how we build that up.
Gotcha. But I guess, what do you typically see customers doing? Do you see them with a pretty substantial, like a large landing zone, or do you see them with kind of a smaller, an extra small landing zone typically?
Yeah, it's interesting in that the VM count pretty well puts us in the right spot. So if they come to me and say, I've got somewhere between 300 and 500 VMs, let's say they say 300 VMs, then we've sized the compute, and we've set the compute count so that there are a certain amount of processor and memory per VM. And so we kind of have a base model there. And then if they come in and say, you know what, I want to go to 400 VMs, then we'll take a look at what those VMs are like. And more often than not, it's adding or increasing the CPU capability and adding some memory. On occasion, they'll come to us and say, I've got a VM that is, it's a huge database VM, and it's 5 terabytes of disk, and it's, unusual, exorbitant amount of memory. Then quite often you'll see additional compute put in that is focused on that particular workload.
Gotcha. Okay. Thank you.
Any other questions around the recovery process, the sizing, really anything at that point? And I will close it out here really in terms of, what's the big differentiators. When I talk to folks, what really grabs their attention, what gets us the meeting to go deeper and start architecting, is really that second row, the data availability. And it comes back to what I mentioned earlier, having to restore from backup before you can start doing anything versus cloning a snapshot. Huge difference, obviously, in time, and that's a big difference at the end of the day on the cost of downtime to the business, because we're able to shorten so much, but also the reputation to the business, right? Business, you look at what's happened down in Vegas when the folks couldn't get into their hotel rooms and they started posting all kinds of stuff on chat applications. It's not good for them that way.